So, and then it'll pop up. But it'll look basically the same thing. It'll just look right this time. All right? Oh, and then so also, so part of the lab is, does anyone have the lab document, lab 5?
Yeah.
Do you want to talk at the microphones?
Good idea. Let me see if I... Okay, so here's the lab. And so what we want you to do is run the same optimization, just the tutorial we did, and turn in the control arm, just a picture of it. It says it to do it at, I think it says, yeah, so place the ISO value at 0.15 and another of your choosing, and take pictures of that and put it into a Google Doc and share it with the ME471 email. And then the second part, now what we want you to do is take what you learned here and apply it to your car. So people kind of been confused about what to do here, so I'm going to try to be real clear. One person on your team will model a part. We suggest doing something really similar, like a control arm from your car. So you only need one person to do that. It says NX, but obviously you'll do it in Catia. So one person makes that model, one model. They give that model to everyone, and then everyone individually and separately imports that model into HyperMesh, meshes it like we've learned in the past labs to do, and then runs this optimization. So you should, and if you want to all do it at the same time together, that's great. Just make sure everyone's doing it on their own machine. And then you can just walk through the optimization, do it. You'll probably get all the same, everyone will get basically the same results, right, because you're doing the same thing. And then you include a picture of that. That's what it says here. So create an NX or Catia model that represents the design envelope for connecting, for like the connecting arm of your front assembly. So make it design space and non-design space. And then, so then decide on loads and load cases. You got to figure out what kind of loads it's going on, where it's going to be constrained at. And then individually import this geometry into HyperMesh. Individually mesh, load, constrain, and optimize your control arm. So basically, do everything that we've learned in the past couple tutorials coming up to this lab. Because like in this tutorial, it's already ready just to put loads and stuff on. And then put all those loads and constraints on there and make an optimization. And then it says make a single Google document that shows and discusses the results of the 6 optimized control arms. So they're probably all going to look the same if you did it all together, but everyone should do it individually, right? And then, so then you turn in that document with those pictures. And then you also, it says, the second part is then start planning ahead for what you are going to do on more parts. What are you going to optimize in the future? What are the most important ones? As part of the final project, everyone should do one optimization. So you should have at least six parts of your car that have been optimized, or 5 in your case. And then often, since you're going to have one person who's the optimization lead, who's in charge of that, they should really try to learn this stuff really well so they can help everyone else on their parts. And it would be good if they did a couple extras since that's their primary responsibility. Does that make sense? But you need to, for the final project, you need at least one part from everyone optimized. So, are there any questions about that? Okay, so like I said, the homework exercise is just plan. Start looking at which parts are we going to optimize, who's going to do what, and start thinking of some load cases and stuff. Some loads. All right?
Are we supposed to be sharing this with you guys and some of the
Just R, right?
I think so.
Yeah,
Well,
just to be where you
because it always says, like, yeah, share
it says with appropriate faculty members, so that's just going to be.
we're doing the grading here.
So,
But I would just get in contact with the faculty advisor there and ask him if he wants to receive all the stuff you guys do. If he wants. All right.
inundated with emails.
See if this one. Okay, so here we're going back to this. Here loaded. Now we have these different pages. Here's the design history, brake, corner, pothole. So this one should work if we do ISO, element densities. Oh, we're on iteration 0. Okay, there we go. So this one ran correctly. See that, guys? That one worked. All right.
What was the difference you said between this part that you loaded and the other? You said something about a block.
There was a little radio button that I forgot to check on. It was on the constraint.